The design of concrete columns may be time-consuming. After specifying the applied loads, it's necessary to consider slenderness effects. You need to generate the interaction diagram, etc. But what about if we could do a preliminary design of a column just with a click of a button? This is Javier Encinas, and today I'm going to present you a new feature in ASDIP Concrete called the Column Design Manager. Let's get started. To illustrate this new feature, I have prepared an example. This is a rectangular column. It's a sway column, so it belongs to the lateral resisting system. It's 12 feet long. And I have entered some loads. It's a biaxial load, so I have entered dead, live, and some wind loads as well. In every case, I entered axial loads and moments in both directions, X and Y, and the top and bottom. To illustrate the moment magnification method, let's assume that these loads come from a first order analysis, so the slenderness effect needs to be considered by amplifying the moments. If we click on the show parameters, this table is generated in the software. Basically, for each load combination, the software calculates the magnification factor. In this case, the maximum is 15%. So these are the magnified moments that needs to be used in the design. Numerically, we can see here that some of the moments are beyond the capacity of the column. So these combinations are failing, combination 2 and 3, and so on. Graphically, we can see here the loads represented by these points. So they are beyond this line, which represents the structural design capacity. So the goal is to find the size of the column and the reinforcing so that all these points representing the loads are inside the usable area of the interaction diagram. Of course, we could do this by hand, just changing the sizes and changing the rebars and so on. But it's much easier if the program can do it directly, just with a click of a button. To do that, we open the Design Manager, go to Design, then Design Manager, and this opens this window here. Here you specify the type of rebar that you want to use. For example, let's say that we want to continue using number 8s for this example, but we don't know exactly how many rebars will be necessary for this optimum design. So let's click on Design, and then the program identifies that you need this many rebars in order to produce this interaction diagram, so that all these loads are inside the usable area. If we go to the At a Glance tab, we can see here that the ratio is 5%, which is pretty much high. It should be in the order of 2%, maybe 3%, but no more than that because of the congestion of reinforcement in the column. So that means that probably we need to increase the size of the column. Let's say 26 by 26. And now let's repeat also the design per the Design Manager. You can go to the Design Manager, or you can just click on this icon here, Design Manager. This time we're going to specify rebars number 9 to reduce the number of bars, and then click on Design to see how many rebars we're going to need. So we will need these rebars, 4, 8, 10, 12. 12 rebars. It looks a pretty good design. Let's go to the At a Glance to see the reinforcement ratio is 0.8%. It's perfect. So let's keep this design. Please note that the program identifies the rotation angle, which is critical in this case, 34 degrees, which means that the critical loads are at 34 degrees from this plane. And this produces this interaction diagram at a rotation angle of 34 degrees. Numerically, we go to the At a Glance tab, then everything is passing for every combination. We go to the Contents tab. It shows a more detailed set of calculations. These are the factor loads. This is the interaction diagram. And finally, the column strength, showing that every ratio is less than 1. The maximum here is 0.97, which is very close to 1.0, so it's very optimized design. Let's go to the Detail tab. This is a more detailed set of calculations, step by step. The column strength with references to the ACI code. And finally, in the Diagrams tab, we can see the 3D interaction diagram for this column and this 2D interaction diagram at a rotation angle of 34 degrees. We can see here the splices regions. So all these loads are falling in the tension area of the splices. So all these splices will be type B, 1.3 development length. As you can see, with this new feature, it's very easy to do a preliminary design of a concrete column. If you like the software, please download the free 15-day trial going by the website www.asdipsoft.com. Please subscribe to the channel if you want to receive notifications of similar videos in the future. Thank you for your attention.